Hi, this video is going to be for subtracting unlike denominators. So before we worked with addition, we've also done a little bit of subtracting yesterday. So this is just to review those ideas. We know that when we are adding or subtracting, that they need to have common denominators. The reason for that is they need to be the same size pieces or the same units that we're talking about when we do subtract. So looking at our objective for today, it says, I am learning to subtract with unlike denominators. So let's take a look at some of the problems that we have. It says 7/8 minus 1/3. So already I'm noticing something about this problem. It has unlike denominators. So when we are subtracting these, I need to be thinking about how I can get these to be the same. An easy way of doing that is just multiplying by our other denominator. So, and that the reason for that being, I know that if I do 8 times 3, that will be the same thing as 3 times 8. I can flip those factors around and it will equal the same thing. When I am doing this, it needs to look something like this. The reason for that being is our carefully chosen 1, right? That's the verbiage that I'm going to start using. So I know that 3/3 is equal to 1. Anything multiplied by 1 is going to be itself. I know that 52 times 1 will be 52. 36 times 1 will be 36. So I'm looking for an equivalent fraction that will have a common denominator. I'm not changing the number that I'm working with. I'm just making it look a different way with a different denominator so that I can subtract those same parts. Okay, so 7 times 3 is 21. And then for my denominator, 8 times 3 is 24. Okay, now for my other fraction, so I know, let me take a step back. 7/8 is then equivalent to 21/24. Okay, again, all I did was multiply by a different version of 1, which is 3/3. All right, for this bottom fraction, again, I do want a common denominator, okay? So I'm going to use 3 times 8, because I did 8 times 3, so now I'm going to use 3 times 8. 3 times 8. Again, I want this to be a carefully chosen 1. I'm going to use 8 on the top to make sure that is equal to 1. For my numerator, it's going to be 8, and of course we know that my common denominator is going to be 24. From here, because I have now the same unit sizes, I'm working with the same size pieces, I know my denominator is going to be 24. Morning. Okay. I'm actually going to pause and show a model for this. Okay. Nope. Okay, for time's sake, I went ahead and drew it like off recording. So this is 24ths. You could pause the video and count. And the tape diagram below is also 24ths. And then here I've colored in 21 24ths. And here I've colored in 8 24ths. Okay. So what I'm doing, since I'm doing subtraction, is I'm finding the difference. That's the answer to a subtraction problem. So I'm solving for the difference. So then I can look at what is the difference between 21 and 8. We know that to be subtraction. So you might already know that. You could just do 21 minus 8 is, and then find it out. You can also use the tape diagram to find the difference between these two values and figure out what that is. Okay. So if I do 21 minus 8, since I know that I'm finding the difference, I can then count all of these. So I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Or I could solve it with an algorithm. So I would know that I have to regroup. And that gives me the same thing, 13. So 13 what? Well, I didn't cut up more parts. I just have 24ths minus 24ths. The difference between these parts is still 24ths. Those are the size of those pieces. A 24th and a 24th and a 24th, and I have 13 of those. So my answer will be 13 24ths. Okay, I'm going to show another problem. So I'm looking at 1/4 times 1/8. When I'm, again, subtracting, I need a common denominator. So looking at 1/4 minus 1/8, I'm thinking about how I can get these to have the same denominator, a common denominator. Well, looking at these numbers, I see that I can skip count by 4 to get to 8. So I don't necessarily need to do 4 times 8 and 8 times 4. I can just do 1/4 times my carefully chosen 1, which is going to be 2 over 2, because I know that I could go 4, 8, and so that's just 4 2 times. So I'm going to go 1/4 times 2 halves, or 2 over 2, and that will give me a common denominator of 8, and my numerator will be 2. So for 1/8, do I need to change it? No, I'm going to use my common denominator of 8 to solve. So I'll just write that 1/8 is equal to 1/8. And again, I'm solving for the difference. So I'm finding 2 minus 1. I could also draw that out in a model. For this one, I know that 2 minus 1 will be 1. And I know from before it's going to be my same eighths. So my answer will be 1/8. Today we practice subtracting with unlike denominators, so we're going to say, I am learning to subtract with unlike denominators. Go ahead and keep practicing.